Great. Well, thanks. Welcome everyone to the Thursday, July 18th edition of the HamSCIence Zoom call, where we try to talk about ham science topics and propagation and heliophysics and magnetophysics and all the other kind of things that we're all interested in that from a scientific perspective. Today, though, I do want to do a little bit of administrative work towards the end of the call. We've got some work, some ideas on a HamSci newsletter, a brainstorm that Ed Fchak here had, and the fact that a lot of us are together gives us a chance to discuss it and think about how we want to move forward in that. So maybe we'll do that about 40 minutes or 45 minutes past the hour, if that's okay. A couple of other things. I am just about done with the solar eclipse QSO party scoring. I'm waiting for some numbers from Cam Cameron. Has anybody heard from Cam in the last couple of weeks by any chance? I want to make sure that nobody's assigned him something he's busy with. So, okay, I'll bug him again and ask him to redo that. But once that comes through, we have our SCQP results. That'll be done too. Let's see. Good. Is there anything that anybody wants to add to the agenda, or is a burning desire to talk about, or any questions or issues that people want to raise today too? I can put on the agenda. Nope, I see Mary Lou joined us too. Ron's joined us. We've got a lot of our academic folks on too, which is great. Ron, I appreciate the photos you sent from the solar eclipse QSO party. I'm using those in the write-up you'll see hopefully in a couple of weeks. So it's from down at Cleveland State. Some good photos there. So thanks. All right. Okay. The only thing that I wanted to bring up is I wasn't quite sure how to handle this because it never happened to me before. Is a gentleman who's a member of the HamSci Grape Google group sent me this scientific paper on E-layer propagation and MSTIDs. And as I think you all know, I'm not of the caliber to judge its worth or its quality or anything else like that. But I did enjoy reading it and looking at some of the ways that the gentleman analyzed the data. I thought were interesting. I think some of them correlate, no pun intended, to some of the things that Mary Lou has been teaching us in our directed lessons a few weeks back. And I've got some questions about MSTIDs and stuff. So I think we've got a couple of people here that might be able to answer them.
I'm actually qualified to answer questions on MSTIDs.
Yeah, I knew that. I knew there's a couple of you are for sure.
But so, I think another good point is I'm really glad he sent that to you, and I'm really glad you read it, and that we're going to talk about it here because I think you said you're maybe not qualified, but one of the things is that when you go to graduate school or to school for sciences, one of the things they have are journal clubs. And you'll often have the students read these journal articles and then present them to the group. And then everyone has a chance to chat about them and you can ask questions. So this is actually how you learn how to learn about these things. So I think this is great.
Okay, good. Well, as they say, sometimes the blind squirrel finds a nut. So I guess I found one. So I'll take that. All right, let me share my screen and I'll bring this up. Obviously, I don't want to go through in detail because it would take hours because it's a pretty extensive paper. Some of you may have looked at it based on the link that I sent earlier, may have additional questions or comments, but that'd be great too. So let me do a screen share here. That's probably not the screen we wanted. Oh, yeah, there it is. Okay. Fold all this Zoom nonsense out of the way. Okay, so this was the paper that Vera sent me. I've not had any correspondence with him since. Of course, I did acknowledge receipt of the paper, and I said I'd be looking it over. So, being the time zone difference, it'd be nice if we have questions for him, he could come on and answer them. But again, given the time zone difference, that might be a challenging thing for him. But anyhow, his main purpose behind the paper is to look at the incidence or the occurrence of MSTIDs and how they may correlate to sporadic E-layer activities. And I thought he said he found some reasonably high correlations. And he thinks there is definitely a connection, but also there's a variation in these activities based on the solar cycle. So we've got a couple of different things going on in this paper, as I can see. Let me skip to the next figures here. So here's, I thought, was the most interesting graphics in the paper, where for 4 different months in 2019, he's comparing the critical frequency of the E layer, it looks like. And the frequencies, and to my way of thinking, seem fairly low. I mean, we've talked about E-skip as a ham. I think of that more as a 6-meter activity, 52 megahertz. But using ionoson data, he's looking at the critical frequency of the E layer being much, much lower. So maybe my understanding of how E-skip occurs and what the critical frequency is measured by the ionosons isn't quite accurate. That was my first observation in looking at this. The other thing, and this is,
do you want me to jump in and make a
oh
comment?
yeah, please.
Yeah, so one of the things to remember is that ionosons, they go straight up and down, typically, most ionosons. And when you go straight through the ionosphere in a vertical incidence, you have to have a much higher higher plasma frequency or density of the plasma than if you are doing like a grazing incidence, so oblique. So if you are looking straight up and down, you're going to have a lower frequency of the ionosphere that to support that wave. Then if you're trying to do communications, then you can it can support higher frequencies obliquely.
Okay, that explains a lot. Thank you.
Yeah, there's something called the secant law, which will uses it relates the vertical incidence with an oblique incidence, and you can relate those the frequencies that you would observe as critical frequencies.
Okay, that helps quite a bit.
Gary, you mentioned 6 meters, thinking of E-skip as 6 meters, but there's a difference between sporadic E and, the standard E region, isn't there? And I'm wondering if with the 6 meters, you're thinking about sporadic E rather than the normal E layer. And I don't know, maybe somebody more knowledgeable can step in on that.
Yeah, sure. So the regular E layer typically has lower, somewhat lower electron densities, and you can get a sporadic E is like this fairly thin cloud of higher density electrons that appears somewhat sporadically. And I say somewhat sporadically is because I guess Jim will tell you that there are ways to kind of predict it, and a lot of it has to do with the occurrence of like metallic ions and wind shear in the E region. So yeah, so when scientists talk about sporadic E, they're talking about the occurrence of these high electron density, somewhat localized clouds that of electron density in the E region. That when ham radio operators talk about it, they're often talking about the propagation that happens to occur most often on the 6-meter band when those sporadic E clouds appear.
Yeah, right. But the sporadic E is much denser than the normal E region. Isn't that correct, Nathaniel?
Yes, that's correct. Much denser. Yes.
Okay, good. Get a couple of these questions answered. Anything else while we're thinking about the E region? Because otherwise I was going to move on to my MSTID question.
Can you, before you, so one question I have looking at this paper is how did they measure the MSTIDs?
Okay, I was going to get there next.
I have one question on the E layer, and I'd appreciate Jim's view on this. It looks from those graphs as if every day for 4 months there was an ES, a sporadic E layer, for which they could get the critical frequency. Would that be unusual to have sporadic E for every single day over 4 months?
I think you're muted.
That. No, that's not unreasonable. In fact, I'd be surprised if there weren't sporadic E, at least on most days up to 10 meters, probably 50–60% of the time. And if you add in the days when it goes even higher, maybe there's only in the peak month, which I would probably put subjectively as June, you'd be looking at something like 85% of the time you would be able to get a measurable FOE's frequency from somewhere within the European domain. So whether it's actually where they're looking over a particular eye on a sonde is another matter, but certainly it's much more common than we think.
Okay. Oh, thank you, Jim. Right, that's helpful.
And the other thing, incidentally, we're talking here of 6 meters, but I mean, there are many occasions when sporadic E is quite detectable on the HF bands, 20 meters and so on. We have sort of vaguely subjective terms like very short skip on HF. I can hear GM stations on 20 meters locally in southern England. That will be sporadic E, and similarly on the LF bands in the evening, you can get a sporadic E patch that's still strong enough to give some better conditions for local nets. So it's much more common, in other words, than I think we take for granted just thinking of 6 meters.
Okay, good. Well, this is helping to sweep away some of my misconceptions, and hopefully the same for the rest of the group. The next thing I was wondering about is the scale for MSTID activity. I've seen this in other papers and other places, and it's a percentage, and it's a fairly small number. My feeling is this is probably a percentage of occurrence on any given day, that an MSTID would be moving over a particular spot on a globe, but I may be way off on that. So I'd like to understand the scale a little bit better, and then I want to get into Nathaniel's question about how they came up with these numbers.
I think for that specific scale, you'd have to see what they say in the paper, because if they're giving some sort of a percentage, you need to see how they define that percentage.
Okay, well, let's scroll up there real quick then. So here is this paragraph on the right. They talk about using L1 and L2 total electron content data, 20 years worth of it, and doing a lot of different math on it to come up with their estimation of MSTID activity. I think this first sentence at least explains the percentage.
Okay. Yes. So delta I over I, where delta I represents the standard deviation of the total electron content perturbations observed in a specific region, and I bar represents the background total electron content obtained as an average vertical TEC over the same area. Okay, so they are using measurements from GPS. So GPS receivers can operate on multiple frequencies. So L1 is one GPS frequency and L2 is another GPS frequency. And the number of electrons between the GPS receiver on the ground and the GPS translator in space will delay one of those frequencies relative to the other as a function of the electron density. So you're able to back out the total number of electrons between the receiver on the ground and the receiver in space. Okay. And so they have GPS receivers that are located in that particular geographic box, which they've defined there. So you can plot that on a map and it shows you where they have those defined. And then they have they've used GPS receivers in that area to measure the total electron content, and then they've done some signal processing on it to figure out some sort of percentage of deviation or TID strength. And so I think this paper looks like it's kind of a short paper. So it looks like they basically it looks like they used the methodology in that Atsuka 2008 paper. So if you want like the details of more how they did that signal processing, the thing to do is probably look at that Atsuka 2008 paper.
All right, very interesting.
Another thing I want to point out here is that you'll notice this paper talks about nighttime MSTIDs. So it's very important to distinguish between nighttime and daytime MSTIDs, because we generally believe they are governed by different types of physics. So usually the nighttime MSTIDs are thought to be caused by some sort of electromagnetic effects or drivers or instabilities. And the daytime MSTIDs are more often associated with gravity waves from the neutral atmosphere. And a big question for a long time has been why? Like, why do you just see the gravity wave ones during the day and not at night? And like vice versa. And I think the reason for that, Sharon Vadas is she's now saying that we know that gravity waves, as they propagate up, they can be filtered out by different directions of the neutral winds as they propagate up from below to above. And it turns out that where the gravity waves are generated and the way the wind patterns typically go from day to night, it actually filters out the gravity waves at night and allows them to go through during the day. So that explains why you only see the gravity wave ones during the day. And then if you look at the proposed mechanisms for the nighttime MSTIDs that are caused by like electrodynamic effects, during the day, you have additional, I believe you have additional electron densities in the ionosphere, and that increases the conductivity along field lines, and that increased conductivity can short out electric fields that are present at night but not during the, and therefore they're present at night, and those electric fields are therefore not present during the day. And those electric fields are some of the things that are responsible for the nighttime MSTIDs. So that would explain why you see the electrodynamic ones at night but not during the day.
Wow.
So that's why they make a big deal of saying that these are nighttime MSTIDs, because when you're looking at this, you have to know that they're probably related, they're all like similar physics here.
Very interesting. I haven't said anything yet, Nathaniel, but a goal I set for myself was someday to understand the MSTID cause and effects and whatnot, and hopefully to someday write a general article for something like a QST, where we could explain this to people and how our research has helped uncover some of this stuff. So I mean, that's probably way off in the future, but that's one of the reasons I'm interested in following and learning a little bit more about this. So we'll see what happens.
That's great.
Maybe somebody will beat me to it, which would be okay too. But... All right.
So what are the 4 different panels there again are, so May, June, July, and August. So 4 months during and this is over Japan. Did they give, right? Is that over Japan?
Yes.
Okay. So this is like mid-latitude northern hemisphere, right?
Right.
Okay. And so that means it's mid-latitude in the summer also.
Right.
The nighttime is pretty short then, isn't it?
Well, it is mid-latitude, so I think it's like 35
north.
Okay. So it's still going to have a reasonable, probably like 8 hours of night, right?
Probably like southern Canada. See here in Cleveland, we're at 41 north, so it'll be south of us.
Yeah. Okay. Is there any geographical locational information on these FOE's nighttime recordings? Are they mapped anywhere?
I don't know if there was any maps in the paper.
If they're measuring FOE, they're probably getting that from an ionosonde, and they probably it says so right there.
It's
on
in the second paragraph.
Oh, sorry.
Second paragraph which you had there.
Page
Right.
one.
Yeah, right above data and methodology.
Oh yeah.
I saw
Koku some.
that's what Tsuko did. So we should look under their data and methodology section, and they should tell us. Okay, I see it right there. Second column, don't move.
Yeah.
The paragraph that says, in this statistical study, the critical
Oh, yeah.
frequency FOES and the blanketing frequency FBES of the sporadic E layer obtained by an ionosonding Kokubunji in Japan.
Yeah.
So it gives you the
Okay.
latitude and longitude of those measurements right there.
Yeah. I see it now. Thank you.
And when they say a blanketing frequency of sporadic E, so normally an ionosonde, if you sweep up high enough, it'll go through the E region and you'll be able to get like F region measurements. But if you have blanketing sporadic E, my understanding is that the sporadic E layer density is so high that you can't get above, make measurements.
So the term is something I'm not absolutely familiar with. So the term blanketing simply means a high magnitude FOEs in.
Yeah, I think I'd have to, I don't fully remember, so I think I'd have to look that up again. But I know I've seen, I think when you see like a blanketing FOE in an ionogram, you'll just see like a big return right at like 110 kilometers altitude throughout the entire day or for an extended period of time from across like all the many of the frequencies. I might be able to find an example of one.
Yeah, I was trying to look that up and I ran out of time.
Yeah, no, that's
Yeah,
interesting.
this didn't help me this much. This didn't tell me anything. But
here, I found it, I think. Well, here's one blanketing. So I'll put this. Here is a paper that comes from the UK, or not a paper, it's a website. But you can see there that it defines under the sporadic E and E sub S.
We're not seeing it.
I guess I'll show it. I just put in the chat. So here it says sporadic E sub S. This layer is a patchy, very dense layer, sometimes exceeding 16 megahertz. Despite their intensity, these layers do not extend over a large height range and do not exhibit an asymptote in the critical frequency as the transition is too sudden. They appear on an ionogram as a narrow horizontal line around 100 kilometers. An intense sporadic E layer can prevent any echoes from reaching the upper layers. This is known as blanketing.
Yeah. So it's essentially an intense, ordinary E's patch that gains the term blanketing.
Yeah. And I was trying to see if I looked in like Google Images.
Oh, there's one. Second.
Right here. Like 1, 2, 3, like kind of like that maybe.
Yeah.
There any other? Yeah, I think I'll just modeled sporadic E layer. I'll turn it. I don't have a great example handy, so I'll just turn it back over to Gary for now.
okay, well, I've found this discussion interesting. I hope others has as well. Let me see what else I wanted to look at in that paper. Let's see. So Mary Lou, you've been helping us with the math on some of these things, understanding some of these correlations and that sort of thing. And
Yeah.
so they've got a graph here of MSTID activity versus the critical frequency. and the E layer. And it looks, we've got a fairly large group here in the 4 to 6 megahertz range, but I think seems like a reasonably good correlation. I think that's the point that he's making in the paper here.
Doesn't look really convincing to me.
Okay.
If you take away the red line in each case, it looks just like a blob of points. Doesn't it to you?
Yeah, I can see that.
I'm not convinced that anything really goes along the red line much. But who knows?
It's an area for further study, right?
Further study. Yeah. When was this paper written?
It was just published in the last month or so.
Oh, okay.
I think it went online in June, if I remember. Yeah, copyright 2024, at least. And this,
All right.
where they're
Hot off
hosting
the
it.
press.
Yeah, yep. So,
Nathaniel, do you know anything about the people who wrote this paper at all? Are they new to you?
Yes, this group is new to me. I don't know this group. Yeah, there's no one on here I recognize.
Where are they from? Where do the little numbers say?
Stastra.edu.
Because they don't all sound like Japanese names.
see if they're at the end of the paper. Or...
2 or 3 of them are from India, I
Okay.
guess, because Venkatratnam and the first author should be from India.
The Shanmungha Arts, Science, Technology, and Research
Sure.
Academy.
You just scrolled past the author details. It's right at the end
Oh, was it?
before
Sorry.
the references. Keep going, right there. India, Japan.
And India and Japan. So Kuldeep, do you know any of these folks?
Yeah, I know Venkatratnam. But his affiliation is not correct. So maybe he's not that Venkatratnam whom I know.
Different one.
Yeah. Otsuka is quite active in TEC analysis over Japanese sector, and others I don't know.
All right. Well, that completes the questions, or I guess you can say some observations I had, and I had no idea that I was doing something reasonably valuable for.
So
I'm glad.
could you read the conclusions, which is just a tad under where you
Oh,
are?
yes.
Yeah.
So the first conclusion is the number that I guess we were questioning. We were looking at the correlation, 0.53, 0.46.
I must say, I find it useful myself to square the correlation coefficient. So of the order of 0.5 becomes of the order of 0.25. And then that 0.25 is sort of an indication that 25% of the variance is explained by this particular this pair of variables. So if it explains 25%, then 75% of the variance is from one or more other causes. And I think that tends to support Mary Lou's view of the blobs on those plots.
Exactly. I was thinking the same thing, Gwen. I was immediately squaring it when I saw the plots and thinking, no, this is not very impressive. But maybe they found something there. Do they say anything about any of the physics of why it should be so? I don't think so here. Correlation coefficient. Yeah. And then so here, number 2, it says the correlation coefficient tends to increase with increasing solar activity. In 4 months, really? Where do they show that?
I believe there was another graph in there that,
Oh, so could you find that one?
yeah, I believe so. It was, here's the solar flux, the 10.7 megahertz flux, which should follow the solar cycle somewhat, the minimum. So the,
And what's the black bit? Oh, that's the F107.
this would have been cycle 24, probably 2014, 2015. And the minimum we just experienced a few years ago.
I'm not impressed by that. What's the blue one? I can't really, something coefficient of something. What is that blue one?
Oh, the delta F O minus B, that's the difference between the blanketing frequency, right? The B and the critical frequency from the critical frequency, the E layer minus the blanketing frequency.
Well, at least it goes down in the middle, like the black one goes down in the middle. Not convinced.
Okay, any more questions? Well, I'll quit sharing that and we'll move on to something else. But I appreciate everyone's input, and the learning, I think, is it's nice for many of us to learn how some of these things work for sure.
I think I found some papers that might show some nice examples of the blanketing frequency. So like I'll put this one in the chat. So the title of this paper is Blanketing Sporadic E Occurrences over Santa Maria, a transition station from the low to middle latitudes in the South America magnetic anomaly. And they talk about how in general the top FT sporadic E and the blanketing FB sporadic E frequencies range from 3 to 4 megahertz between 100 to 110 kilometers, with more pronounced values during the daytime compared to nighttime. And I think they show so here are ionograms from 0 to 14 megahertz, and it has examples of sporadic E blanketing layers. And so if I blow that up, so here you can see this ionogram is showing very intense returns from 100 kilometers altitude going all the way up to 10 megahertz. And so that's the sporadic E blanketing right there. And then I think here's an example where maybe you have blanketing down here, but not up here. Here's an example where you have some blanketing going on down in this region. And again, blanketing over here.
Nathaniel, I'm trying to open it, but it says that I need access. So if anyone else is trying to do that, you might find it.
Oh, really?
Yeah. So, I mean, if there's a way to move the PDF around it, that might
be I
guess
disseminate it.
Mm-hmm.
I can't legally do that.
Yeah.
But I can tell you, based on AGU's policies, that so they make everything open up 2 years after it's published. So if you wait till December 16th or maybe December 17th of this year, you will be able to get this.
It's a note to your calendar.
That's right.
There's lawyers involved with everything, aren't there?
Exactly right.
Yes.
I went to the wrong business.
But the other thing is if you go to your local college library, or even maybe your public library, they might be able to help you get it
There you go.
legally.
Okay, well, great. It's nice. We had some very interesting observations about the paper, about what it may mean and what it may not mean too, conversely, I suppose. I wonder if I could ask Jim Bacon a question. I think it relates to last week. We were talking about wind shear, sporadic E, and I think you mentioned the term, was it meridial or meridian wind shear? Was that versus longitudinal?
I think somebody else mentioned that, but it is
Okay.
in some of the papers that have been published on it, it's quite clear that the two behave differently. I think maybe it was Alex's paper that gave some reference to that, but they're not exactly the same. So you do get slightly different behavior. I couldn't quote it to you off the top of my head, but it's in the literature somewhere. What I tend to find is that the zonal wind flow is a very good way of understanding, you know, the difference between east and west contraflow in the E region is a very good way of capturing it, as I think Alex had last week. But it does behave slightly differently, and I think it's a difference that's not just the fact that one's zonal and one's meridional differences, but I think the effect is different at different heights as well. That at one height, the zonal winds are more important at getting the convergence of the ionization to compact into a thin layer. And at another height, the meridional influence becomes more dominant. But I'd have to look that up.
No, that's helpful. The reason I brought it up is when I left our call last week, I was reading, I don't know, The Economist or something, and I was reading about hurricanes and hurricane formation. And they talked about how the upper atmosphere wind shear can help break up or weaken, I guess you'd say, hurricanes, if I remember what I read correctly. And what I started thinking about is as our Earth warms up, will that wind shear become stronger, a greater differential, say, between east and west, and affect our sporadic E? You know, long story short.
Yeah, well, I think you're right to ask the question about ionospheric impacts of climate change, because I'm pretty sure there will be. It's not my field, but I think there's a group at Reading in the UK who've done some work on this. And from the hurricane perspective, I think fundamentally it boils down to the energy stored in the oceans, that as the climate warms up and you get warmer oceans, you've got more energy to generate circulation of the hurricane. And probably you could imagine it might make the season expand in duration. So if the seas are warmer to start with, you know, you get into that critical tipping point earlier in the season. The other thing that might change is the larger scale upper wind regimes, which tend to contribute to the formation of hurricanes. So you can track them back, the Caribbean sort of generation of a hurricane. You can usually track it back to a wave in the upper atmosphere easterly flow across the equator over West Africa. And you can track these easterly waves, as they call them, coming across the mid-Atlantic. And when they reach the Caribbean, they form a sort of supportive mechanism for getting some uplift going, which is obviously helped by the warmer water, which releases the latent heat as the moisture condenses, and that's where it gets its energy from. So there's several ways in which I think there's feedback there, which is quite interesting and potentially all going in the wrong direction.
Interesting. It's as they say, may you live in interesting times, and we live in interesting times for more than one reason, for sure. All right, if I can move us away from science a little bit to some of the business of HamSCI. There's one thing I wanted to share. Nathaniel mentioned Liz McDonald earlier, and Liz is the PI behind Aurorasaurus, and also very active, right?
Yeah, she's not only the PI of Aurorasaurus, she's also a like actual NASA employed citizen scientist. I'm sorry, NASA employed scientist assigned to working with the citizen science groups. So she's like a NASA program officer or
So
project
she
scientist.
has a lot of interest in knowing how many people participated in the various eclipse events. And it was a simple question she posed to Nathaniel and to me. It's how many people participated in your event? And it's difficult to count that from a ham radio perspective, but I thought I'd give it a try. And this is what I sent to her, so I might as well share it with everybody. Let's see. So I went back and looked up Nathaniel and Ward Silver's summary from 2017, and you know, one measure of activity, of course, is how many logs did people submit for the solar eclipse QSO party. And we changed the rules slightly from year to year, and so these things aren't exactly a one-to-one correlation. But anyhow, we did pretty darn well in 2017 for our first time. We had a lot of competition, other things going on that weekend, so we dropped off, and then we picked right back up again in April, on April 8th. So I think we had a lot of people that submitted logs, both the SEQP and the GSSC, both. When it came to counting participants, I couldn't get into too many ham radio details with Liz. So what I did is I looked at, you know, not only the number of people who submitted logs, but the number of call signs who appeared in those logs. Because if you appeared in somebody's log who entered the contest, you made a contest QSO.
Right.
Whether you made 1 or 500, you were participating in our event. So those are the where I came up with these two numbers for 2023 and 2024. Pretty nice.
I think that's great.
So
So
then,
4,000 people and then 6,000 people. That's
Yep.
neat.
right,
Yep.
right. Another thing is a kind of ham radio data points that I could directly attribute to either the SEQP or the GSSC, the people who entered. So that was their two-way contacts and their logs, the number of whisper transmit and FST 4W transmit and receive record, just for the people who entered. And we had about 100 people enter the GSSC. So this number from a whisper perspective may seem small, but from the fact that HamSCI may have helped boost our overall numbers is pretty nice. The more impressive thing, I think, is the what I call the superset of all data points recorded on eclipse days. And I pulled this again out of Nathaniel's various articles and papers, about 2.5 million in 2017. And I don't have enough access or understand how to pull all the data for 2023. So I think 7 million is pretty low, especially knowing that Bill Engelke and his Madrigal project is working with 52 million data points for 2024. So anyhow, I think everyone who participated in the events, who helped us plan them, who helped us promote them, and spent a lot of time on this Zoom call for about 1.5 years, did a darn nice job, because we had quite a bit of success in these areas. Okay, close that up, and we'll turn the floor over to Ed. Ed had a great idea about a HamSCI newsletter, and this also kind of fits in with our Daisy 2 grant, which is going to the mill at the moment, believe it or not. But Ed, why don't you pick it up?
Thanks. Yeah, thanks everybody. So yeah, and just, I mean, going back to the metrics, I mean, just in the back of my head, I always said if we could do one better than what we did in 2017, I'd be happy with it in terms of log counts. So it was nice to see that. And also keep in mind, everybody, that for October, we were up against a couple of big contests like the Pennsylvania and California QSO party. So we've got a lot of that data that's mixed in there. And obviously a lot of people came back to us in April. But anyway, over to the newsletter. I mean, one of the questions, I guess, sort of putting my marketing cap on is, without an eclipse, where do we go? In terms of really sort of, getting the word out regarding HamSCI and keeping people's interest, particularly in the amateur community. And one of the things that I thought about, and this is just sort of a rough skeleton of our thinking on this, is sort of create a quarterly HamSCI newsletter that talks about the association, talks about its membership, talks about some of the work that we do, and be able to disseminate to as wide an audience as we can at the beginning, sort of based off of our mailing lists, and then really look to grow it from there. So the what is really, again, sort of the creation of a HamSCI newsletter. The when is we made an executive decision just ahead of this meeting is that, we're looking at Q1 2025, but realistically, we can do this in Q4s for 2024. And there's some reasons that Nathaniel pointed out in terms of working with other groups, that having something, done and published I think would really work to our advantage. So, I mean, from my standpoint, Q4 24 would be our target to get it out. So the why, there's a lot of boilerplate here, and certainly a lot of it, I guess, from the marketing standpoint, looks a little warm and fuzzy, but there are really some good reasons to do it. I mean, first of all is to maintain interest in better understanding ionospheric radio propagation. Obviously, there was a lot of buzz about what we were doing. Obviously, showed up in in the contest results, and sort of how do we keep that going and sort of keep the momentum going, that type of thing. Is that we want to retain awareness in HamSCI and the work that it does post the 2024 eclipses. We want to act as a conduit for dissemination of HamSCI work and findings. Obviously, we've got a lot of analysis right now in the works. How we get that out is not only through what we do in terms of our emails on our website, but this is something a little bit more formal and sort of systematic in terms of its look and feel. It's an opportunity to give back to the amateur community for working with us in citizen science and in sharing scientific information. It gives us the ability to assist in the recruitment of amateurs, keep the word going and the visibility going, and others obviously interested in what we do, to assist in the development and hosting of ongoing scientific experiments. It's an opportunity to say thanks. Okay, give back is another piece just regarding that. Thanks to Gary, AF8A, for visibility forces us away from complacency. I think when we do our HamSCI flag, we're going to have that copy line sort of running underneath.
I think there's a lot of truth to that.
It doesn't get better than that. So, but yes, I mean, I think if you focus that as the theme, we don't want to be complacent, and by not being complacent, we become
much
more
truth
visible.
there.
Yes, the guillotine focuses the mind, said another way. So, anyway, and obviously we want to be able to grow any HamSCI related interest groups. I'm a marketing guy. Okay, I'm self-serving. I want to grow mailing lists. Grow is an operative word for marketers. And we obviously want to link HamSCI to other relevant organizations, individuals, and the amateur radio community to help us just get the word out and make us larger and more famous in terms of what we do. So, it is obviously in a world of digital, if there's no QST, most people don't read it anymore in terms of print, but obviously this is a digital publication, just saves on costs, and it certainly helps us in terms of dissemination. Who's involved to be HamSCI contributors? And I suspect from the standpoint of this audience on a weekly basis, raise your hand because you'll probably be the staff helping us to put this out. Because obviously it's one of those pieces that you can't necessarily do it alone. So how, again, we're going to leverage our mailing list, our website, and our social media channels, at least in getting started. Again, this is just a rough skeleton, okay? I'm thinking about this. I mean, if you got 2 pieces of 8.5 by 11 paper, I mean, that's what I'm sort of thinking about in terms of the initial starting point in terms of content, sort of a 4-page print newsletter equivalent as a starting point.
I just had a
sure, go ahead, Nathaniel. Yeah.
Couple of quick thoughts.
Yeah.
One is, have you met Hahwa Hamano yet?
No, I can't say that I have.
I think you should meet her. So she's the person that was leading the Telecon before. So she's actually employed by NASA as like a presidential fellow or something to kind of coordinate the citizen science for the heliophysics big year.
Yep.
So we actually fall under this NASA heliophysics big year program. Yep. And she's actually a former NPR person. So she she comes from the media world, not from really the science world. But and she's also into like these zine things. I think maybe Gary, you can put Ed in touch with Hahwa, and I think you two should talk. And I would like Hahwa to know that you're doing this.
Yep.
And then I think it might be cool to at least for this issue and maybe for the next few years through the end of the heliophysics big year, we can have a notes from NASA section, and then you could actually have like Hahwa actually say a few things about how this fits into the heliophysics big year.
Yeah.
And that way we get something not just from HamSCI from ourselves, but we actually have a NASA person saying I like that. I like that a lot. Yeah. So that just extends the credibility of it right out the door. And then the other thing we need to make sure we have on the bottom is we have to have an acknowledgement statement that says we gratefully acknowledge the support of the National Science Foundation and NASA and the ARDC and just we can work on. I can work with you to come up with a boilerplate statement or something that will make the program managers happy.
That'll be great. I like it.
Yes.
So, yeah, and that makes, it just makes for a better overall piece. So it's all
Yeah.
good. So anyway,
Great.
go ahead.
Yeah, this is wonderful.
Yeah. Yeah. Just, I mean, in terms of content, I mean, this is just sort of off the top of my head, but obviously, we're drafting Nathaniel to do sort of a quarterly piece, from where I sit, that type of thing. Sort of a synopsis of latest findings. Again, it sort of goes back to as we roll data out, it leverages not only our existing sources, but it puts it in a different place and it moves to a different audience. Just a quickly sort of a summary of anything that we do in terms of press summary, sort of HamSCI in the news, feature, and here, obviously here, this is, where again, I'm sort of looking at a template. It's going to have a similar look and feel from quarter to quarter, simply so that people, sort of identify with it, in terms of what it is, and also it makes it easier for the contributors in terms of making contributions possible. Having done a lot of newsletters, working from a template just makes it easier for people to work on it. So it'll be a feature on a HamSCI contributor, / scientist from the scientific community. Also, sort of somebody from the amateur radio community, who can speak obviously to what their contribution is to HamSCI, how they feel about it, and how they sort of, why they're involved in the association. Radio amateur involvement and contributions to recent activities that certainly have some relevance. An update on experiments, upcoming events. Certainly the workshop would fit in terms of that piece, as well as any other thing that we're looking at doing that sort of is scientific in nature, that's beyond sort of what we've done for the eclipse. And obviously a lot of the boilerplate here is how you can get involved in terms of working with us. Certainly some boilerplate in terms of looking at citizen science, back to sort of why we're here. Okay, and sort of keeping that front and center for people. Certainly, just again, sort of boilerplate about what HamSCI is, so we keep people involved, and obviously here the acknowledgement statement. Again, what I guess this is just sort of sort of brainstorming out the door to get started. I guess where I'm looking at help, okay, is that if anybody, I'm really a word person, far more than a visual person. So if anybody knows somebody who's a graphic artist who might be able to help in terms of creating a template with me, that would be something, I guess, off the beginning that would be helpful, because it gives me a guide in terms of looking at the look and feel on it. So I mean, so that's sort of the first and only thing I think I need in getting out of the box, other than obviously as we get a little bit more in terms of more, we got an idea in terms of content and what sort of what that first issue looks like. I can get back to people, just more specifically that way. And I guess I kind of sort of fell off version to version. I've got a sort of working title on this, which I call the reflector, for nothing else other than the fact that it sort of reflects the ionosphere. So I mean that might be
that's also the name of a journal in astronomy.
There you go. So I mean that might be.
I think, yeah, I think I'd like to see some name for it that evokes a little more ham radio, or
there you go. Okay.
The radio reflector could be okay, but
yeah, so there you go. So, but I mean, we'll sort of put that out as a group note and sort of maybe crowdsource it. I know with other newsletters, it's always, it's the group that comes up with the best name. So we'll figure something out around that. So, but that's where I am right now. And obviously, I mean, the big thing is that we'll do it in for before the end of Q4. And it will not be a problem to be able to get it out. So be prepared. I may be calling on you, okay, if you're out there, okay, to help out in terms of just things that we need to get it out the door. So that's my report, Mr. W2NAF.
That's wonderful. If you need a graphics artist template, if no one else steps up, I have been able to get the University of Scranton's graphic designer to help out with a number of things.
That'd be great.
She's the one that did the SCQP logo for this year, the banner. So she's done a few things for us. She's done our the W3USR QSL card. So
yeah, hold that thought, because I think once I've got a little bit more in terms of what the content should look like, I could even take a ride up. Okay, we may just do like a quick lunch or something like that.
Yeah, that sounds great.
That'd be perfect. Okay.
Yeah, I think all of this sounds really exciting and really good. Thanks, Ed. I just want to say I really like these cards that we made up. I carry them in my pocket, and I gave out a bunch at a baseball game in Allentown over the weekend. I had no idea what these people are doing with them, but they said, "Oh, that's pretty," and they took them. So there you go.
Yeah. Well, if anybody's at Ham Expo, Okay, I'll be bringing cards up in August, so maybe we can meet there too and sort of talk about it around the table. So
One of the interesting things I suggested and he's got it in there. I said, we need to have some update in our experiments. We got various networks, the GRAPE 1 network, the GRAPE 2 network. We hope to have the HFLF magnetometer network next year, the year after. I said, we should have, I would love to see somebody volunteer from the GRAPE organization or the GRAPE group to kind of keep an eye on those things. How many people are alive? How many stations are reporting? If somebody drops off, do we follow up with them to see what happened? Maybe we can move their equipment around and so on and so forth. Okay,
Yep.
so that was one idea. But at the same time, Christina Collins, I find out, Section 5 of our DAISY grant application, there's a thing in there about regular updates of what the network is doing to publish some sort of newsletter updates. And here we are. Here's our vehicle.
yeah, so Christina and I have obviously talked, since then.
It's just funny how some of this stuff works together and fits together like a puzzle sometimes.
So and that's a good point, Gary. Just sort of regarding things that other groups or people are doing, but also keep in mind is I'm the ham, I'm not the scientist. So I'm going to do obviously a lot of reliance, in terms of what that content should look like and what's out there in terms of getting it out and what's important, obviously in a 4-page newsletter or 5-page newsletter. So
yeah.
Anyway, that's where I am. So thank you.
Nice, Ed. Looking good. That's pretty impressive. Another feather in HamSCIence cap eventually, I'm sure. Okay. Is there anything else? Wow, that's pretty good, Ed. You finished at 4:59 and 14 seconds. That's not so bad.
I tried.
Timely.
Yeah. So, anything else anybody's got? Otherwise, we'll call it a week. And
what time
Jim
does the
and I
5 o'clock meeting
reschedule.
end, right? Mm-hmm.
What's that, Ed?
What time does the 5 o'clock meeting end?
Yeah, right.
Yeah, Gary.
Yes.
I've just spotted we've got our last contest night next Thursday for the RSGB, which the Norfolk Club goes in for, and we're currently leading. So it's all hands to the pumps to keep the lead. So I'd rather not do next Thursday if that's possible. So I could move it back a week further than that.
How about August 8th? Because
perfect.
Chris will be speaking on August 1st, so we'll have you on August 8th. Okay, wonderful.
Yeah, great. August 8th. Make a note of it. Thank you.
Thank you. Thanks for being flexible too. Okay, anything else? Otherwise, we'll call it a week. All right, thanks everyone. Hope you enjoyed the call. I appreciate everyone's participation as always. It makes it a whole lot better. So, all right, 73 all.
Thanks,
Have a good week.
Nick, call Patch if you want to stay on for a second. I'll talk to you about your email.